Science in pajamas. Pew, pew. All right. So, in this one, we're going to talk about friction. So, friction is essentially when you have two surfaces that move against each other. If anyone's ever fallen and scraped their knee, that is a painful version of friction. So, what happens in friction is the slight imperfections. Very few things are absolutely 100% smooth. So the slight imperfections in one surface interact with the slight imperfections of another surface. And because of that, it causes a resistance in motion. The imperfections kind of get caught on each other, and it causes a slowing down effect on motion. So let's see. Think about this. If you were to drag something across the desk, you can actually kind of sometimes feel it kind of getting like a little bumpy a little bit. And that's because you're trying to overcome, and I don't want to say rise above, but you want to be stronger than the objects getting caught on each other. And that's what we're dealing with. Now, there are two main classifications of friction. There is kinetic, which we know kinetic refers to motion, and there's static. So static friction is when you get an object that is at rest to move. So for instance, I got my prison break Rick given to me by a friend. So here he is. He is currently stationary on my stand. So he's stationary. Now, right now, he is experiencing static friction. When I push on him, I have to overcome the friction as well as gravity. So when I do that, I am overcoming the static friction. Now that he is in motion, he no longer has static friction, he has kinetic friction. And there are two types of kinetic friction. This one is sliding. So sliding is when the same surface of one object is in contact with your ground. So you have them there, he's sliding over it. The other type of kinetic friction is rolling friction. Now, if you notice, balls tend to have less friction usually than a box. And the reason for that is the surface that is in contact. You know, some kids are probably saying, yeah, but it's round. And what does it do because it's round? It rolls, which is why we call it rolling friction. But because of that, as it moves, there's a different part of it in contact with the floor at each moment. Since it's not the same surface constantly in connection and getting caught, we are switching up which surface is in contact with the floor. So that means that the friction, the surface that's experiencing the friction, is always in constant change. As a result, you tend to have less friction because of it. Yeah, excellent. I definitely wanted to mention that. All right. We do have an equation that goes along with friction. We'll just kind of do a brief look at that. Nothing too big. So we have kinetic friction, or the force of kinetic friction, equals the coefficient of kinetic friction. So the force equals the coefficient of kinetic friction times n. And in this case, n is looking at the weight of an object. Now, as you know, weight and mass are not the same thing, although they are related. Mass is how much matter makes up a substance. Weight is actually the force of gravity pulling on the mass. So when we talk about weight, we can think of it as mass times the acceleration of gravity. Weight is a force. It is the force of gravity pulling on your mass. So weight equals the mass of you time, or the mass of an object times the acceleration due to gravity. And we know that's 9.8 meters per second squared. All right, so we can also think about this in terms of static friction, which is just force equals the coefficient of static friction times the weight. All right. So let's take a look at this. We have a couple examples that we're going to solve. So a force of 54 newtons is needed to start a box sliding across the floor. Weight of the box is 58 newtons. So we can see a force of 54 newtons is needed to start a box sliding across the floor. A box sliding across the floor. The weight of the box is 58 newtons. All right, so we have a couple questions. First off, how large is the force of friction? Well, they tell us that. Force of friction. So the force of 54 newtons is needed to start it. That means that you need up to that point, it won't move because of the friction holding on to it. Once you overcome that, now you can get it to start moving. So that is our force of friction. So force of friction is 54 newtons. Is it static or kinetic friction? The key is in the wording. What you have to ask yourself is this box already in motion, or do we need to start the motion? Well, it says here we need to start it. That means it is at rest. And if it's at rest, it is static friction. All right. So now why don't we go ahead and figure out the coefficient of friction? It didn't tell us that. That's either something you're going to calculate like this, or you can look up in a database. So we know force of static friction equals the coefficient of static friction times the weight. We're going to rearrange this to solve for our static, or our coefficient. So divide both sides by n. And we have us equals Fs over n equals 54 newtons over 58 newtons. So mu s, or the coefficient of static friction, is, 0.93 newton. 0.93. Yep. There you go. Not too bad. Not too bad at all. Let's do another example. Give me one moment, you guys. All right, there we go. So, if the coefficient of kinetic friction between a crate and the floor is 0.35, so if the coefficient of kinetic friction is 0.35, and this is between a crate and the floor. How much force is needed to slide a 84, so an 84 kilogram crate. All right. So we want to be able to slide it uniformly. So that means at a constant velocity. All right. So we know our coefficient. We know our mass. We just have to solve for our force. So force of kinetic friction equals coefficient of kinetic friction times the weight. We know mass, but we don't know weight. Remember, mass and weight are not the same thing. But don't worry. You know this. You got this. We know the coefficient of our coefficient of kinetic friction is 0.35. And we said we know we can find the weight if we have the mass times the acceleration of gravity. Well, they give us the mass, 84 kilograms, times the acceleration of gravity, which is 9.8 meters per second squared. So even though they didn't give us the weight for this value, because it gave us the mass, we're able to figure it out. So we have coefficient of friction times the mass of an object times gravity or gravitational acceleration, and we get 288.12 newtons. All right. Not horrible, right? Now you guys got this. All right, you guys. So that's it on friction. Until next time. Take care. All right, you guys. Bye-bye.